with AI and so on. Also, you can see several highlights here that I will talk about motivation for new functional materials design. I also want to give you several examples of new technologies that were designed in Israel for functional applications, including sensing, and also several examples from our group in design of new materials like permanent magnets, shape memory alloys, and probably some others. So the main motivation why we need to design new materials, and actually these our main research agenda of our additive manufacturing center. So the main motivation is that materials are limited. And you know, also in this slide it is presented the map of European Union that we have critical raw materials. And here additive manufacturing came as a game changer, because we are talking about technology that is low waste and in some cases zero waste. Also, this technique enables to design microstructures, alloys, and composites that could not be realized or designed by any other technique like casting, forging, or forming, or others. And especially it's relevant for the design of printed electronics and functional materials. So I can say that in Israel, 3D printing, we have really good positions in that. Each university and almost each faculty has its own additive manufacturing lab, 3D printing lab, for very different applications, including architecture, industrial design, biomedical, and aerospace. I can say that the most famous name here is Stratasys, that was one of the most successful now global companies that designed their own additive manufacturing technology, material jetting. But even now, even in last decade, we have new names that came to the market with the new technologies overcoming well-known limitations like multi-material production or smooth surface design and others. I will show you just two examples. And can you please run this video on the butterfly without sound? And the first example is devoted to nano-dimension 3D printing solution. As you can see here, the overview of the machine, and here is schematically the process. So one of the main issues and challenges in additive manufacturing, if we can print very different material in one layer, and here they did it. And you can see that two print heads depositing the conductive DIO, the metallic DIO, and dielectric material as a base. And there are many, many applications in electronics, in printed electronics, that could be realized by this technique. The main application here is for sure multi-layered rigid printed circuit boards, but also this company has already patented solutions for side contacts, antennas, printed capacitors, sensors, battery circuits, and others. And I will show you just several examples of these solutions. So first of all, you need to think in 3D. So you need to think about 3D process that we deposit our materials layer by layer. And in this case, there is not an issue to put side contacts on the PCBs. In traditional manufacturing, it is an additional post-processing, additional step. Here, it's one process, and no any post-processing is needed. The idea is very simple, like the basic idea, the fundamental idea of Internet of Things, to make our devices as small as possible and as smart as possible. And if we can use each piece of area, even the sides of our PCBs, so we can assemble additional components into the device. This example that you can see here on the next part of the slide is devoted to another advantage, that our technology, when you print the required geometry without zero waste, it is ecologically friendly, it's environmentally friendly, and there is no waste. In traditional manufacturing of PCBs, this will require cutting process, drilling process, and these wastes are really polluting. So I can say that it's really a significant advantage of this technology as well. Another example Also, you can see if we are print no matter what in layers, the 3D geometry, you can also print like stairs in the PCB and use both the top surfaces and the side surfaces for additional contacts. And here you can see again another example, the socket that was printed together with this PCB, all the contacts. Again, there is no any post-processing. The conductive part and the dielectric part all was realized layer by layer in one process. And the second example, the traditionally manufactured antenna and PCB with antenna and the printed one. Here the printed one antenna was designed and manufactured in one day. Another issue that we also often heard about additive manufacturing, that additive manufacturing is not competitive in terms of lead time and productivity. But here, if we are talking about very small devices, like in this example, PCB with antenna and holder, here, by the way, they were designed as one part, one piece, and were manufactured overnight 500 pieces. So from my point of view, it's a really good example of mass production and serial production in 3D printing of electronics. Just two more examples about this technology, the RF signal transmission microstripe and the touch switch, the touch sensor. Here you can see that this demonstrator was designed, printed, and assembled and tested within one day. So the conclusion about this technology you can see on the slide. Mostly I have already spoken about them, just additional one, confidentiality. Because especially when we are talking about trade secrets, that we want to keep the company secrets, it is very important that all your designs, all your solutions will be in-house. And here, because if you have no any post-processing, you don't need to send your PCB, your device, for additional cutting or soldering. It's all in-house in one machine, in your lab, and in your company. So in this case, it's also more effective. Please run this video for me. Another example was also designed based on the material jetting technology. And here the idea was to overcome another issue. Because in the typical industrial additive manufacturing, we have an issue of the very rough surface. Rough surface could not be used for antennas, for electronics. Here we need really smooth surfaces. And this company, XJet, and their process that you can see schematically in this video, they used nanoparticles powder that was put into the cartridge in the form of suspension. And together with the cartridge of the material, they also designed the cartridge of the support structures. And in this case, you can realize very challenging geometries. Yes, you can see here the support material and the metal material. They are printed together. And what is important, these support structures are soluble. So after the part was printed, you just put into the solution to remove all the support material, to clean the channels, and you have a very smooth and accurate part. There are already several materials released by XJet, including ceramics, alumina, zirconia, and including metals like stainless steel, some other steels, and if I'm not mistaken, titanium alloys too. So if you are interested in the process and in potential for new materials designed by this technique, go over through these papers. So, in the terms of sensing, electronics, antennas application, I can say that this technology is extremely relevant, because if we are talking, for example, about design of antenna, usually it is done in some with the accurate detailed geometry by specific software, and we have to be sure that our process can make this geometry feasible. Also, smooth surface, as I said. For the wave propagation, we do not want any surface roughness to deflect the waves. Details, if we are talking about very small components, here you can design components as little as 500 microns, and the holes, the channels could be even less. Density. Density is also extremely important for the antennas applications. And what is even more important, not only to be 100% dense, but also to have the uniform density in all directions, in all axes. And easy. It's also very relevant, because if we are talking about digital manufacturing, we do not want to look for very qualified personnel. We want to make this process very user-friendly and operator-friendly. And since here we use just such cartridge with the material, there is no powders, there is no melting, even safety closures you don't need for this process to operate this machine. The only issue, if you want to go into this market with some new material, it will take R&D efforts to make it as suitable and as effective as already released materials. And the following examples I will show are from our laboratory, from Additive Manufacturing Center. We are dealing with more simple processes. We are talking about metal powders, ceramic powders, and blended powders and composites. So all the mostly industrially applicable processes like selective laser melting, electron beam melting, directed energy deposition, it's all about our agenda. When we are talking about powders, we need to understand the key factors that affect on our material. Yes, here in many presentations you see the ready devices, and you also in one presentation they were talking about high-strength steels and aluminum alloys. But to go into this product, we need just to think a bit what we do before, and how our material, the quality of our powder, the particle size distribution, the tendency to oxidation will affect the final mechanical and functional properties. Here, when you already have your material and you put it into the machine, again, you have a lot of challenges, the process parameters optimization, and you also have many capabilities how to functionalize your part. For example, in this case, in this simple example, when you print the yellow area once, affect with the laser, with the energy source, and the gray area twice, you have already designed two different microstructures. And all the properties that are microstructure sensitive, like hardness, thermal conductivity, tensile strength, they will be different in these two areas. And we can use it to design some specific channels even in the part, even having one material. The situation will be even more interesting if you will use the blended powder. Like you can see here, we use the blend of molybdenum, chromium, aluminum, niobium, tantalum to design a very new alloy, high entropy alloy. And here you see the samples, and it is also an example how we design the specific microstructure. Because here, the idea was not only to have the five elements composition, but also to have the specific microstructure of the solid solution, because this will result in high mechanical properties on elevated temperatures. Another example, when we use the blended powder with two of these powders, and you can see that in one material, in one part, we can graduate the microstructure from the composite structure into alloy structure. And this will result in like modern way of making Damascus steel, when you have the ductile core and abrasive surface. Also, I like this example when you use metal and ceramics. And this microstructure with these white spots of tungsten carbide, it is an example of very ordered structure that you can produce only by 3D printing. And the next part, I want to show you how we can print magnets. And okay, when we are talking about metals, about mechanical properties, it's very understandable. But when we are talking about some functional properties, like conductivity or magnetic properties, it's more challenging. For example, here in the manganese aluminum alloys, we know that we need the specific metastable tau phase. And how to achieve it, because in traditional manufacturing, you need quenching, you need the very rapid cooling. And in additive manufacturing process, we actually have this mechanism. With advanced scanning strategies, we can make cooling rates and heating rates extremely fast. So here you can see the results, our powder, our printed samples, and even in as-built state, we have already found up to 10% of the required phase, and the amount of this phase was increased up to 90% and even more by heat treatment. And actually, it was a very nice example how functional materials could be printed by additive manufacturing. This work was done in the frame of European Horizon 2020 project, and it was awarded as a key innovators, our 3 organizations, Technion, Fraunhofer, and Technische Universität Darmstadt. And also we published it in a top journal in our area, additive manufacturing. So for those of you who are interested, you are very welcome to see it. And the last example that I want to show you that not always we need some very tricky powders, some blended powders to design something new. In this case, it is the most popular process, selective laser melting. We used the pre-alloyed powder. You can see very nice particles with good flowability, but the material was nickel titanium. It is also a very well-known alloy, shape memory alloy, but to get this shape, can you also run for me this short video here? And to design this shape memory alloy, it will also require the process parameters optimization to have this phase transformation under, sorry. No, video doesn't work? This one? Okay, now it's run. So you see that the printed part was deformed, and now we put this inside the hot water, and the metallic part just returned into its initial geometry. So it's a good example of the shape memory alloys that I use both for sensors and for biomedical, for actuators and for other applications that also could be done with our equipment. So the short summary, as you can see in this slide, 3D printing now works together and develops together with functional applications. And there are many work, R&D work, and also work together with the industries, how we can design new functional materials, and how we can promote additive manufacturing and 3D printing into functional applications like shape memory alloys, permanent magnets, sensing, and others. And I hope everything was clear. And thank you very much for your attention.
Thank you. 感谢 Vladimir 博士的精彩分享。通过刚才的演示呢，我们对增材制造技术在提升功能性传感器性能方面有了清晰的认知。接下来我们将聚焦协作机器人与具身智能机器人在实际应用中的发展趋势。有请深圳市粤江科技股份有限公司华南区域总经理殷志辉先生上台，为我们带来主题演讲：协作机器人和具身智能机器人行业应用和发展趋势。掌声有请殷志辉先生，有请。
非常感谢大会给了我们这样一个机会哈，与在座的众多优秀的企业和我们一些社会的这个群体人士哈，来去交流探讨啊关于粤江在这个技术领域的一些相关的一些情况。OK。首先允许我简单介绍一下粤江公司的这个情况哈。这边是粤江的一个相关的标签。那这里面的话有没有提到的是关于粤江的这个创始的一个历程？粤江公司的话是2015年啊在深圳成立。当时的话我们创始的团队的话创业的初心就是希望能够打造全球最好的机器人。那么截至目前为止的话，粤江的话是中国第一大、全球第2大的协作机器人公司。那我们目前的话也是中国的第一个 上市的协作机器人企业，也是目前唯一一个上市的协作机器人企业，拥有众多的国际领先的一些相关的技术，那么也有大量的这个全球首家独发的这个相关的一些那个技术专利等等内容，那这里面内容比较多大家的时间也比较宝贵，那我们进入下一个那个给大家分享的一个内容哈。这边的话是关于粤江的一个全球化的一个布局，因为粤江从诞生之初的话就是一个全球化的一个公司，我们的大量的这个产品的第一波的这个客户的话，就是来自于全球各个不同地区的客户，粤江的话是一个众筹起来的公司，那么我们当时的众筹的第一批客户的话，主要是来自于这个 Kickstarter 这个上面的一个专门的众筹平台，所以当时的这个产品的话，也受到了全球各个不同国家和地区的这个相关的一些那个要求和考验，所以后续的话，我们在整个生产制造维度的话，其实已经在那个很多的这个专门的一些那个内容里面做了很多的这个优化。那我们整个生产的一个分布，还有说公司的一个分布的话，基本上也是围绕着目前我们整个全球这个专门的这个热点生产的这个地区和制造地区来分布的。总部的话是位于深圳，那么我们在其他地方的这个分子公司是罗列了部分大家可以了解一下。截至2021年的话，我们已经发现，就是粤江的整个对于产品这个要求，还有说客户的对这个产能的需求已经无法满足粤江的这个高速发展的这个所需，所以我们在山东日照打造了全球最大的协作机器人生产基地，那这个生产基地的话，设计的这个年产能是10万台我们之前有非常多的这个相关的合作企业，有专门到粤江的这个相关的生产位置去做过考察。那么基本上调研之后的话，大家的一致评价就是粤江整个的生产规模、生产的规范化生产的这个所使用的一些专用的这个设备和设施，都是他们认为业界最好的。这个是我们山东日照的生产基地的一个简要介绍视频那我们在生产的过程中的话，已经实现了通过机器人生产机器人的这样一个生产的这个模式。接下来给大家分享一下粤江的这个产品的一些相关矩阵。粤江的话是全球首个推出机械臂加人形加6足的具身智能机器人平台的企业。那目前的话，我们的产品有5个系列，30多款型号负载能力的话，从0.25千克到30千克都是有一些分布。那这个部分的话是介绍的是粤江的这个安全皮肤。那众所周知的话，传统的这个机器人的这个安全的这个触发的话，通常是由这个触碰之后触发。那触碰之后触发的话，它其实容易带来的问题是什么？在这个触碰的过程我们这个对相关的这个生产作业人员，或者说我们的一些相关的生产的产品已经产生了一些损害那么粤江的这个电子安全皮肤技术的话，我们可以实现在碰撞之前就实现停止另外的话，我们还在安全维度做了非常多的一个考虑。例如说我们假设一个极端情况，我的人员故意去冲撞我的设备，那这里面的话其实有可能会发生那粤江的话，针对这个部分的话，它有一个技术这个电磁爆炸技术，它可以实现在碰撞之后在1个毫米的这个范围内实现这个停止。那传统的这个业内的这些机器人厂商，大概它的这个停止的这个距离相同技术层面下的话，在8个毫米左右 所以粤江的话，在这个维度的这个技术的话，其实是远远领先于行内的这个大部分的企业。那粤江的话，不止从那个硬件维度做了一些考量啊，我们在那个软件的设计啊相关的话做了大量的一些投入啊。那么像我们的这个安全维度的话，里面有20多项的这个安全的机制啊，有双冗余的这个保障，确保我们的整体的这个安全性啊能够得到非常大的一个提升啊。这个是我们软件模块的啊，软件的话它有大量的这个相关的一些应用的这个选项啊，有这个独特的这个报警模式啊，然后如果是说触发这个需要去实现避让或者说停止的话，有这个缩减模式啊，有这个多维度的这个 I/O 输出的模式啊，还有轴部的一些那个相关的约束。这里面分享的是我们在那个行业的一个保压上下料的一个应用。那么在现场的这个应用中呢，人工的操作不当啊，比如说过渡点的这个设置错误啊，来料的这个问题啊，或者说其他方面的一些情况啊，有可能会导致这个机器人产生这个撞击的这样一个现象。那么对于大多数的这个行业的友商而言的话啊，它的产品不具备碰撞回退的功能。那么机器人的这个撞击力量的话，它有时候可能会很大，甚至超过了关节的这个连接固定的这个相关的这个力矩值。这个会导致关节壁的话容易产生这个损伤，最终无法实现这个比较好的一个应用啊，甚至说原来的这个运作的这个点位的丢失啊。那粤江的这个6轴的机器人的话，带有这个碰撞的回退的功能，在发生碰撞时的话会提前卸力，会根据碰前的一个相关轨迹自动去回退指定的这个距离，保障机器人的安全和使用寿命啊。同时，大多数情况下的话，也无需去担心调好的点位无法使用的这样一个问题。这边的话是应用了粤江专有的这个指令，可以实现视觉的飞行拍摄，大大的提升视觉的拍摄和检测的效率。那在一些应用场景中的话，我们有做过测算粤江的整个的这个飞拍的功能，过程无需停顿大概整体耗时30次拍照的话，只要10秒钟左右。那传统的这个友商的话，它没有具备这个功能30次的拍照耗时去到21秒，大概需要耗费传统的这个就是粤江的这个时间去到传统的这个时间的话不到1/2。那这里面的话是粤江的这个 B 的这个绝对的定位精度。那行业的通常的定位精度的话，去到0.5以上的这样一个水平。那粤江的这个绝对定位精度的话，是可以控制到0.2到0.4的这样一个范围。这原因的话，是因为粤江在整个生产的这个环节的话，投入了大量的这个高精尖的相关的这个生产的设施和模块包括说我们整个准入还有说那个检验的这个过程的话，都是十分的规范的。这里的话是关于粤江产品的一个全球化的准入因为前面有分享过粤江的话，其实我们的早期产品，我们第1代的用户就是来自于全球不同的地区，所以我们的产品在早期的话，已经针对不同国家和地区的专门关注的重点和标准做了很好的这个适配所以我们现在的整个产品的话可以很好的服务全球各个不同国家和地区的相关的用户。那针对不同的这个企业它可能会有一些不一样的这个应用的这个场景和要求为了去适配更多的这个客户的一些应用的要求我们其实有大量的这个生态合作伙伴可以去做专门的一些应用的落地那像这里面的话只是简单的分享了部分的这个合作伙伴譬如说这个相机末端夹爪力控传感器，还有移动平台等等我们可以根据一些专门的要求去选择适合的这个品牌和型号。接下来给大家简单的分享一下这个行业的一个发展的状况。协作机器人的话，它区别于或者说人形或者说我们多轴形态的这个机器人，它区别于传统的这个工业机器人那目前的整个应用的边界的话是比较宽的我们在第1产业、第2产业、第3产业其实都有大量的这个落地和应用的一些案例。这个部分的话是展示的粤江在那个工业场景的这个部分的应用内容 那么人机协作和柔性制造的话，这个需求其实为这个整个行业的发展带来了大量的这个市场。那现在粤江的这个产品的话，已经广泛应用超过于200个工业场景。那全球500强的话，有超过80家正在使用粤江的机器人在做他们相关的一些生产和服务。行业的话涉及到像那个山西然后汽车制造、半导体、食品、化工、新能源金属加工、船舶、制药等等。
世界500强汽车制造商丰田携手粤江机器人，实现汽车检测和总装2大核心工艺的自动化升级。粤江 C2 系列协作机器人具备高度灵活性和产线适应性，在丰田汽车车间发动机组装品质检测中，粤江机器人通过倒装方式灵活部署，无需改变原有产线布局，使生产质量和效率双重提升。粤江机器人集成高精度视觉系统，实现高精度识别与定位，在有限空间内精准检测发动机10多个关键组装位置，以高标准成就高品质。此外，长臂展高节拍的粤江 C2 系列协作机器人，其末端集成组合式夹爪，可一次从切割基础抓取多个看板，并精准放置到各层料架，提升分拣效率30%，基于先进控制算法，确保动作快准稳。粤江汽车制造解决方案全面覆盖从电子元件制造到汽车结构件总装的5大关键工艺，超20家世界500强头部汽车企业选择。
那这里面的话，有非常多的这个应用案例的这个展示因为时间的问题的话，就不给大家耽误太大的时间但基本上的话，截至目前为止就是包括说从刚才我们看到的这些案例都是全球非常知名的这个跨国企业。那为什么那么多的这个跨国企业愿意选择粤江原因的地方的话，就是粤江在早期的话做的这个产品成熟度确实是非常不错那截至去年为止我们在全球的这个累计的这个合作伙伴有超过60%都是来自于海外也正是海外的及国内的这个众多的应用需求也反推让粤江的产品不断的去做升级和进步那这里面的话是给大家看到的是关于商业场景的一些应用的案例那商业场景的话，其实我们最常见到的像这个咖啡像奶茶像这个调酒像这个炸鸡、炸薯条还有一些拍摄相关的运镜直播已经有大量的这个应用的落地。那像我们有非常多的这个海外的来宾比如说咱们在深圳机场容易看到粤江的这个产品譬如说在雅朵酒店譬如说在莲花山公园，大家在散步的时候也能够很轻松的去获取得到粤江的这个机器人产品所生产出来的这个相关的一些内容。那这个是在医疗领域的一个部分的应用的分享。这个是我们在欧洲最大的临床实验室Liber Berlin， 还有美国的 Packing Elmer 等全球知名的这个医疗实验室里面的一些应用。那粤江的话也目前成功服务众多的理疗和康复机构截至2024年的话，粤江在全行业范围内的话，率先实现手术机器人应用数量超过200台的这样一个里程碑事件。这是在医疗还有说生命科学相关领域的一个部分的这个应用的展示这里面的话，像我们日常的这个理疗、按摩、艾灸等等的话，也已经进入寻常百姓家我们在很多的这个相关的一些机构、康养院等等的话，都能够看到的相关的一些身影。这个部分的话是关于教育领域的一些应用。那粤江的话，截至目前为止的话，已经和全球超过6000家顶级的这个科研医院校实现这个相关的合作。那关于这个模块的话，我们预计整体的这个全球的科研教育协作机器人，2023年到2028年的话，复合成长率去到43%。那粤江的话也是希望说以 AI 加机器人的这个模式推进产学研的这个协同发展。现在教育的话确实非常卷现在从国内的这个中小学 到一些职校、到高等院校、到海外教育等等的话，其实机器人的这样一个应用的话，或者学习已经成为越来越多的这个国家和地区的一个常态和形态。粤江为什么去布局这个教育领域呢？因为粤江不仅希望说为业界提供非常好的这个产品，同时也希望能够孵化出来一大批非常优秀的这个行业的专业人才。接下来给大家分享一下一些部分的这个产业的创新应用。这个是复合机器人的一个应用。那这个应用的话，在我们众多的这个加工企业里面的话，都很有机会能够去应用得上，因为我们发现有大量的这个应用场景，它其实是这个加工的节拍相对来说不需要特别快，但是对人的话有一定的需求，那其实很多的话是一些取放、搬运的等等这类型的一些场景。那如果是用传统的人力来去实现的话，这个人力不仅耗损巨大，而且作业的这个质量的话，有可能不够标准，或者说很难达到我们更高的这个要求的水准。那么我们通过复合机器人的形式的话，底部是这个 HV 上面是叠加我们的这个机械臂那可以替代人去做非常多的一个应用的操作。接下来这个的话是关于这个油性工作站的一个介绍。那么传统的这个生产的这个类型传统的自动化它比较适用于这个品规比较少、产品生命周期比较长的这样一些那个产品的生产。那但是多品规、小批量、换线频繁的这种生产模式的话其实传统的这个自动化线它很难满足。那如果是说一般的这个手工线的话，它也很难去确保这个生产的这个质量和节拍。那么针对这种离散制造的这种场景的话，粤江专门研发出来了这个叫油性工作站的这样一个应用的这样一个内容它可以实现的模式是什么呢？我整个生产线的话，它的油性程度会非常高。比如说传统的话，如果是用那个纯这个自动化的这个模式，例如说我有2种产品。这2种产品的话，它的这个峰值的产能需求都是50%，但是同时一起生产的时候的话，它的峰值的产能的话只有85条的这个需求。那这种情况下的话，传统的方案我为了去满足我的生产所需，我需要配置100条自动化的生产线，但是全年算下来的话，我的这个设备的这个动用率的话1年绝对不会高于85%。那粤江的话，目前的这个油性生产的模式的话，我们可以设置85个工作站，我的产品大部分的话可以做到这个90%以上的这个标准化。那剩余10%左右的这个模块，我可以根据产品生产所需去灵活的去配置，那这里面的话就可以实现了这个生产的这个生产线的这个复用另外的话，我针对需要换线的时候的话，我的拆旧的成本也会非常低同时的话，它可以把整个的这个良率和生产的节拍的话做一个比较好的一些那个融合。下面是我们的关于这个油性工作站的这样一个运作的这个模式其实我哪里需要这个人去做运作，那我只要把这个移动工作站调整到专门的位置就可以了。
粤江机。
这边的话是我们在那个3C 组装领域的一些那个简要的一些案例的这个分享那搭配这个我们末端的一些相关的这个感知传感模块我们可以实现非常高精度的这个定位和确认那我们现在在像一些那个 PCB、FPC 等等的一些那个组装装配过程中的话，已经大量应用上了这样一些那个内容。目前这个的话是我们在一个非常知名的这个化妆品就化妆品的这个品牌里面落地的一个案例这里面用到了大量的这个磁悬浮的这个应用的这样一个那个概念
delivering flexible and highly responsive production for you. Centralized industrial system design achieves efficient integrated development and production. With a flexible and agile intelligence ecological deployment, we quickly respond to global production demands and adapts to macro environmental changes.
因为粤江团队的话，我们从基础的应用到行业的这个顶尖的应用，我们有大量的这个落地和实践的经验，所以目前也大量的这个企业寻求粤江来去产出自己更合适的这个自动化生产的一些那个相关方案。 接下来是关于具身智能的这个相关内容的分享。那么全球的 AI 机器人市场的规模的话，从我们的这个目前的预测哈，截至到那个2030年，这个市场规模将会去到367.8亿元。那具身智能的话，它可以赋能各行业最终进入千家万户那这里面的应用的话，涉及到那个工业制造、商业应用、医疗看护、家庭服务等。那过去的这个传统的这个工业机器人它更多聚焦在是一些那个准确和重复的一些工作内容。那其实未来的话，我们更多的是拥抱这个不确定性。这个是部分的一些技术维度的内容。我们有大量的这个多模态的感知模型，有这个虚拟迁移和泛化的这个平台，包括说垂直领域的一些操作模型。 及基于 LLM 的规划大模型等等。那粤江的话是目前全球首家将 AI 加协作机器人进行商业化的公司。那么2024年4月份的话，我们率先推出了具身智能机器人 S Trainer， 并且在多家制造业的龙头企业实现落地。那么这个产品的话，它的一个作用是什么呢？ 因为现在大量的企业的话，它需要孵化自己专门的这个大模型，但是这样的大模型的孵化的话，它通常需要非常专业的这个技术人员。那其实这样的技术人员他不容易找得到，另外即使有，他的时间不一定那么灵活。那么粤江的这个 S Trainer 的这个赋能平台，它可以通过数十次的这个模拟和训练，让整个机器可以复现90%以上的这个相关的应用内容。
嗨，我是粤江机器人 Atom。
接下来这个是我们人形的这
先拿2
个
片全麦吐司
做早餐的这样一个应用的内容。
拿2片生菜，多拿了，放回去吧。这么细也难不倒我，2个手指拿个车厘子来点缀，再倒牛奶补充蛋白。 我去上班了。
这些都是实拍的哈。
好的，不客气。你好，这是你要的文件资料。好的，没问题。
那这里面的话是继续给大家分享一下哈，就是现在整个行业的关于这个机器人的发展的我们自己的一些看法哈。那其实以前的话，像传统的这个工业机器人， 它需要去做落地的时候的话，它需要更多的这个外围的这个集成的这个配合啊，来去实现这个相关的操作和应用。那么随着到后续的话，协作机器人的这个产生啊，那么我们整个集成的这个成本会进一步的下降啊，因为协作机器人的话，它的这个本身产品对外围的这个安全性啊，还有设置的这个场所要求，还有人员的这个作业要求等等的话，都会远远的这个好于传统的这个工业机器人啊。那么再往上的话，其实就是我们更多形态的像这个人形机器人。那么我们现在的生活所见到的非常多的这个基础设施，都是以人作为这个基准的去做一个相关的设置和应用啊，所以到人形啊，我们能够具备更广泛的这个泛化能力之后的话，那集成的这个部分的话，它的要求就会更低啊。这个是关于这个传统工业机器人协作机器人，还有说未来的人形我们的一个简要的分享。那从专用到通用未来从 To B 到 To C 具身智能的机器人的应用场景，它非常广阔也是需要我们非常多的合作伙伴一起去继续拓宽。好，以上感谢大家。
谢谢，感谢殷志辉先生带来的精彩演讲。粤江科技的产品和解决方案已经是广泛的应用于工业自动化、智慧物流、教育科研等多个领域，为推动机器人产业升级和智能化发展提供了重要支撑。接下来，让我们用热烈的掌声，有请来自阿拉德乌雷尔弗莱库大学的 Valentina Emila Ballas 教授登台。他的演讲主题是基于模糊逻辑的机器人与自动化领域传感器性能提升框架。Let's welcome Professor Valentina Emila Ballas.
Good afternoon to all of you. First of all, I would like to express my appreciation to the organizing committee for inviting me here, especially to Yuki, who wrote me quite every day and invited me so nice. Then I would like to extend my greetings to all participants here. Maybe they are from academia, faculty members, students, and also from industry side. I'm very much impressed about what I saw yesterday and today, and I switch a little bit my presentation to show what I was doing in these years and maybe to help you in your activity, but I will skip more slides. So I am coming from Romania, and my presentation will be first related to some few aspects in my university, my work, and maybe will help you for your future publication. So Romania, you can see where is in Europe, southeastern Europe, near the Black Sea, near Ukraine, near Hungary, Bulgaria, Serbia. And my country, it's here in this map. You can see my city, Arad. It's near the Hungarian border, very near, and near the Timișoara, the city of revolution. And this area over the mountains, Carpathian Mountains, is Transylvania. You know, it's Dracula country. The castle of Dracula, it's near Brașov. You will see a small picture soon. And the capital of Romania, it's Bucharest. Bucharest, it's 600 kilometers far from Arad. So other 6 capitals are closer to Arad than our capital. Capital of this region until the Danube, Arad, Timișoara, Reșița, it's Timișoara. The name is Banat. It's the most richest area in Romania because we have a mixed population, Romanian, Hungarian, German, Croatian, Jewish people, and many others. And in Transylvania, we have Cluj-Napoca. Few images from my city, City Hall, the old fortress, Catholic Cathedral, Orthodox Cathedral, and in the center you can see the City Hall. Right side, we have in this building our rector and few services. Why the name Aurel Vlaicu? Aurel Vlaicu was a pioneer of aviation in Romania. He died very young, 30 years, and there are 3 different aeroplanes. He was studying engineering in Budapest and in Germany, and then he came back, he worked in Bucharest. He had a flight over Arad, so we have the name of our university. This is the new building. This is another building that we receive in front of the City Hall, and our university with 9 faculties and so on. But why I introduce you all? Just to arrive here, I propose to all that are working in academia to try to sign MOU with us and to have such visits for students 1 semester, for professor 1 week, mobilities paid by European Union, so Erasmus project. Here you can see in these pictures 2 students, 1 from India, 1 from Taiwan, who visited our university and stay 1 semester. I showed them many nice regions. I invited them in our house for Easter time to see our traditions and so on. We had over Erasmus project, you can see here in 2023, 2 professors from Taiwan. Professor Lin, here he's occupied mainly with the autonomous car, and his colleagues related presentation, we can see failure prediction in robot arms. I'm here with other professors from China that came in Romania in 2009. I organized at that time a big conference, China-Europe, on intelligent systems and vehicular communications. Other professors from India, they visited our university. With Rajib, I visited the Peleș Castle and here Dracula Castle, you can see, and even one Dracula who came from UK only for fun. This is also Dracula Castle. These are other professors from India, from Taiwan, and here 2 professors from China, from Guangzhou University. It's my friend Guozhun Wang from Computer Science Department in Guangzhou University. We had a project, bilateral project. We must also see if it's possible to have such project. And the project was related to biomedical sensor networks. They stayed to us 1 week. I showed them the university, the city. They presented nice talk and so on. Few things about my activity. So you observe in my title the term fuzzy. So I was very much impressed, and it was a big influence on my activity and on my husband's activity. Professor Lotfi Zadek, who was the father of fuzzy logic, 1 component of artificial intelligence. So on my doctoral thesis, he put his signature because we met first time in France, in Annecy, where I was 3 months to prepare my PhD degree in a team of Laurent Foulois. The subject was intelligent sensors with internal model and fuzzy techniques. So I prepare many courses for students. I am teaching system theory, electronics, discrete event system, soft computing, artificial intelligence, and so on. Measurements. Many books that I prepare, starting with 2007, I am publishing in Springer as editor and author, co-author. Many books, chapters. Also, I publish in such journals like here or here, ICI journals, Romanian journals, foreign journals. These are in different databases. This is my supervisor for Polytechnical University in Timișoara. He put in my hand first time this fuzzy logic in 95. So the father of fuzzy logic came in Arad to my invitation in 2003 and he received Doctor Honoris Causa. And from that moment we started to collaborate over our correspondence and different conferences. In 2011, when Lotfi was 90 years old, I was there. Then in Japan, in Kyoto, I visited many times. Here it's Professor Michio Sugeno. Unfortunately, he also died 2 years ago. He visited many times in our university, giving lectures related to his unmanned helicopters. We were very much impressed because nowadays we have drones. So in 96, again with Lotfi, when he was 95 years in Berkeley, and after that, I was near him. Here is the group in Berkeley, starting with Ronald Jäger, with Michio Sugeno, with Janusz Kaszprik, and many others from Brazil, Vladi Krajinovic, and so on. People working in fuzzy. In 2017, I was in Baku for his funeral. And last year, I was visiting Baku over Erasmus project, and I was to his monument there in the cemetery of academician and of president. This is one of my journals where I am editor-in-chief together with Dan Caralescu from University of Cincinnati. And the greetings in 2008, when these journals started, was written by Lotfi Zadek. I remember at that time, and also in my books as a forward, Lotfi wrote that it was 2002, 2003, he said that the future will be of small sensors, many sensors connected that will give a lot of information, and put all this information together, we will have a precise information. And he gave me the example of Professor Chris Pister from Berkeley. I saw he's the head of a laboratory now in Berkeley with millimeters dust, smart dust, and also synthetical insect. You can check on internet, very nice research. The second journal that is very much wanted by Chinese people, they send me quite every week. It's Compendex as recognition. The other one is Scopus, and many other journals, but I want to show you my conference that I am organizing every 2 years of computing and applications. I started in 2005, again with Lotfi Zadek, with Michio and other famous professors around the world. They came in Hungary and in my city, in Arad. I started after IEEE to publish in Springer, and you can see different editions with famous professors from Italy, from Hungary, from Germany, from India, best student paper. Here it's also, you can see Professor Pan from Nanjing University. He was working before in Fujian and in Harbin Institute of Technology. He came in Romania and he asked me to organize that conference, China-Europe. Edition 2020 was online, 2022, where we offered Dr. Honoris Causa to academician Janusz Kaszprik and to another academician from Leuven, Mark van Hulek. And here are some few journal where I am associate editor and I invited you to publish. So it's IEEE Industrial Informatics and IEEE Transactions in Fuzzy Systems. Impact factor it's 11, 12, something like this. Then the other one, Informatics in Medicine Unlocked. Also associate editor, another one, Intelligent Technologies, and another one, the blue one, it's a Romanian journal, very good, Impact Factor 2, and down, Acta Politehnica Hungarica publication, it's for free. I am responsible with 2 series in Elsevier, and I invite you also to publish as author or as editor, guest editor. One book it's related to complex systems. I am working together with Dumitru Băleanu, who is #1 in the world for fractional order systems. And the other one, it's my series on biomedical engineering. So I am publishing a lot as guest editor, as author or co-author in Springer, in Elsevier, and in Francis and Taylor. If you try to find on Google, here it's an image with me, few pictures, and many books. So the content of my presentation, I will go very fast because I know the time is short, and even I introduce another presentation, and I want very much to be presented because, as I said, I was inspired by your presentation, by your companies here, and I introduce few subjects. I will not insist too much on every slide, there are too many, because some of them are related to automatics, but many things I translate together with my team from automatics to sensor, such sensor, intelligent sensor, different technologies for fusion information. So even the term, it's fuzzy, and many papers, if you will try to find my page in Google Scholar or in ResearchGate, where you want, in MDPI, because I am collaborating a lot with them, you will see papers in fuzzy. So fuzzy, it's in fact, as Lotfi said, a precise mathematics of imprecision. So everywhere around us, there are a lot of uncertainties, and we need to cope with them and to find a good mathematical model to introduce them and to take care of them in our process. So I was inspired about papers of Professor Zadeh and Michio Sugeno. Here we are in 2007 in Oradea, in that conference. And I introduced slowly a whole family of such controllers that can control very high nonlinear systems. So usually linear systems, we are doing models just to understand, but it's not reality. It's an idealization. So in my development of this kind of family of controllers, I try to introduce such interpolative networks that are different than neural network. So in these slides, it's explained what is doing one, what is doing the other one. And our approach is related to such fuzzy interpolative controller. Why I introduce this? Because in many applications, even using sensors, even introducing inside a sensor such kind of controllers, we can have a very good response for our system. So such fuzzy controllers are consisting an interpolative network with linear interpolation, very easy to develop using lookup table in MATLAB. We were inspired in our work by these 3 different papers or group of papers so Zadek, Sugieno, Bauer, that controllers, they approximate any finite n-dimensional function with arbitrary precision. You can see there how we approximate that black line with the red line, and if we will have more granulation, we will be more near to the first line. But it's okay introducing such rules. Then the paper of Stoll, and then Cloxin, Morgan, and Laurent Foulois. I was inspired starting from that period when I was in ANSI. So qualitative control method that was introduced by Laurent Foulois and his team. Here are some aspects not to confound with fuzzy rule interpolation that was launched by our friend Laszlo Koczi from Budapest and Kaoru Hirota. And here it's the fuzzy interpolative methodology tools, what means to introduce and to organize such controllers. So in automatics, you know, we have how is the evolution of the error and the derivative of the error. We are interested in such trajectory to go to zero, to have the error zero. And then the second one is the McVicar-Veland tables, where we introduce rules just in the same way to go in the center of the table. And down you can see interpolative networks, so the lookup table, very easy to develop. But to understand everything, you need to know classical automatics. Otherwise, it's not so easy. So we have here two steps, fuzzy set and fuzzy theory, and then linear interpolation. So fuzzier is using during development, interpolation during implementation. There are some other rules for each steps for A and B. I will not insist, are related to fuzzy knowledge. And what is interesting here, it's about this term world knowledge that Lotfi Zadek said many times to introduce. So world knowledge is the knowledge that we acquire along our life using our experience and by communicating. So it's about an information that can be explained in words, not in numbers. We try many times to propose to Japanese usually to organize such an ASIC circuit, because such a controller, it's very useful. Along my course in India, Gyan course, where I stay 10 days, I had this topic, and I proposed this specific controller to put in any kind of process. And even they had power systems, even they had artificial pancreas, other kind. They took out their controller and put our controller that was giving very, very good results. And nobody was interested. Then it was very easy to solve, because with the student we developed on an Altera board such a controller. Here it's a Verilog HDL, and here is the whole family of such controllers that we develop along some good years. So first one, plane, surface adaptive, interpolative, fuzzy self-adaptive, and fusion fuzzy self-adaptive. I will not insist, only few results you will see. So of course we made a lot of simulations in MATLAB, Simulink. Here is the first member of the family, red one, and the second one is in this figure, so fuzzy self-adaptive interpolative. We complete the first one with other blocks, and some good results. You can see how is the step response for a PID controller and how is the step response for fuzzy self-adaptive interpolative controller. And other small rules that we need to introduce just to organize such controllers. We have 4 groups for possible operating regimes, so G1, G2, G3, G4, G1 transitory, G2 steady, oscillating, and unstable. And here you can see few of them. everything related to evolution of the error and the derivative of the error. So this one, G2, it's okay, going to 0. Oscillating, it's have oscillation, big or small oscillation, unstable. And here are heuristic adaptive rule based. There are only rules. Someone asked me one time in Spain in a conference how I can demonstrate my controller it's stable. It's stable because by rules is forced to go in the point that I want to go or very near there. So here are the rules introduced in this table, the error and the change of the error or derivative of the error. Very easy, all rules are introduced like this in numbers. So to understand everything, as I told you, is good to know classical automatics. Here it's how is the trajectory in the state space for a third order system, for a simple PID, and for a fuzzy self-adaptive interpolative controller with small oscillations. Here are big oscillations. So as going further to the last member of the family, it's in this figure. So we have more blocks, we add fusion, we had adaptation, and so on. And here are response for such a controllers. So there are also some oscillations, but in the case of a third order system with big delay. Then there are many applications. I will only tell you in few words because I started to work first of all. My background is electronics and telecommunications, but I switched to automatics and artificial intelligence. I started to work in an airport 4 years and then 9 years in an institute for research for railway coaches in Arad. It is the big factory, the biggest factory in southeastern Europe, and we export such railway coaches in all countries in the world. Unfortunately, nowadays we are producing trams and only few railway coaches. So our first applications were related to such a air conditioning equipment, and the second one, ABS braking, using such controllers and using some specific sensors. Here are some response for different controllers from the same family. You can see large oscillation, small oscillation. So even introducing adaptation, auto-adaptation, we can have good results. Here is for an ABS lag controller. So we are interested to have all the time the real speed of the car. Here it's the speed that we collect from transducers, and is not always the same. And here it's what is happening for adherence perturbation. Here it's a perturbation smaller, and there are some advantages for such controllers. Here I will introduce, as I told you, such sensors with internal model and fuzzy techniques. Here it's a well-known process identification by internal model. So we can find the internal model doing this diagram, some explanations, and the same thing I introduced for a sensor, an intelligent sensor. And the intelligent sensor I put inside the internal model of the process. And what is here, from the plant, we obtain different output that we will fuse together with the output that is given from the internal model. And in this fusion block, we are doing a fuzzy fusion process. And at the end, we will obtain a precise information. This I applied in the case of the ABS. We have also such a corrector. And here are all relations related to the previous figure. we will obtain a high reliability. And what is here? The fuzzy fusion car estimator. We introduce from each wheel the transducer that gave the speed of the car. So we first put in a block that will detect the maximum speed, because each wheel, when start the braking process, will be different. And the maximum of this speed we will introduce in this fuzzy fusion. Then we introduce an accelerometer that will give good information during the sliding of the wheel over the rail, because it's a railway coach. So the second information is from accelerometer, and at the same time we can detect and measure the adherence. That it's a term that has no possibility to be measured, adherence for a car, for a railway car, and so on. So we introduce also the computer model. We have 3 different information, and we will give, let's say, a weight. That means a credibility for each information, like to neural network, and we will do a fuzzy fusion. We will obtain a good information at the end. So this was an important thing that I wanted to introduce, intelligent sensor. Here is the estimation of the adherence, and as I said, inside of this sensor we can obtain combining information that we obtain from the computer model and so on, the estimated of the adherence. Very, very important. So there are some sensor issues cause instability and even mechanical shocks, because the robot rely heavily on feedback loops, where sensors provide information to controllers, even if that sensor is incorrect, delayed, noisy, or inconsistent. Which are the causes? You can see noise, sensor delay, quantization and resolution limit, sensor drift. There are also sensor fusion, conflict, fault, and dropout, observer estimator instability. So we need to take into consideration all these causes. Sometimes can appear maybe those who presented us robots, maybe there are some problems like this which appear during the research phase. So modern robots often use Kalman filters, neural estimator, and even there are some problems. So our team developed 2 approaches against these artifacts. So the fast high dynamic imagery, I said about such a sensor, that is very useful for medical applications. So the idea is to take 3 different frames, one that is to improve the final image. So 3 different and combine through linear combination. The last one is the safe commutation of controllers and sensors. This is a problem that is important, related to switch control instability. And how we solve these problems, you will see in this slide. So here it's a slide related to Y hybrid controllers. So we have good for steady regime, but bad for transient. For transient, in the first moment, here is a transient regime, is not okay. Here it's related to another applications that maybe, yes, I will stop very soon. I will not present you that rooftop greenhouses. I want it very much because I know that your city is so green, and even I saw that you have such rooftop greenhouses. So we can use such fuzzy interpolative controllers. In the other figure, you can see they are very good for transient regime, but they are not very good for steady. Here it's the output external temperature. Here a green line is the temperature on the rooftop greenhouse, and red one is the temperature in the building. The idea in that application is to organize two flows to take carbon dioxide from upper side, from the rooftop greenhouse, oxygen to introduce inside the building, and from the building to introduce their carbon dioxide. So many things I want to tell you. What is here, only few things. So if we switch from manual to automat, pilot or control for a sensor, for a robot, for in this case an airplane, for even a nuclear plant, it happens bad things. So happens that thing in Chernobyl. Also for airplanes, it's about fatal airplane crashes. It happens. When we switch from one regime to the other one. Why? Because the output of the controllers are not the same from one to the other. And here I have explanations. I will stop very soon just to show our solution. So switching, the next controller will go up or down, but not will maintain the trend. And it happens many times for digital systems. It's happening this, but we are looking to the error between these two controllers and the evolution. And inspired by sliding mode control, commutation is not good to be in the first or the third quadrant, only in the second and the fourth. And here is the last figure where I want to show you what to do. These are some case studies. This is an unstable when we switch from one regime to the other one, so going up, going down for different time. This is somehow turbulent, somehow good, but with oscillations. So here is the solution. So the active controller that we want to commute to the other one, to unconnected controller, we have the output of the first controller given for this tracking controller just to have the same value, because here is the problem. The value is different, so will appear big problems. So here it's a stand in our institute where I was working in Astra Railway Coaches in Arad. When we produce cars, we recorded always the lines in the country where they are working. So this evolution, vibration, was introduced on a real dimension stand for the real railway coach. And we were doing a lot of experiment like this to see if it resists. There are other important research that we were doing. They are very good for automat cars, for such maintaining of the distance between cars. And I wanted only to show you that Renault company use our research, and using this time to collision criterion, they obtain economy in fuel gas of 35%, and so on. I will stop here. I wanted to tell you many things because we have a lot of applications, but I invite you to see our research paper and maybe to come in Romania to see us in our university. Thank you very much.
好的，感谢博士的精彩分享。那么接下来呢，我们将进入一段短暂的茶歇时间。在20分钟之后呢，请大家回到会场，我们继续进行会议的议程。Now it's a tea break time. We can have a rest. We will back in 20 minutes. See you soon. 尊敬的各位来宾、女士们、先生们，欢迎回到会场。经过了短暂的茶歇，我们将继续下午的议程。接下来有请深圳市新京城科技有限公司副总经理孙建龙先生上台，演讲主题为六维力传感器助力 AI 智能机器人高速发展。掌声欢迎孙建龙先生，有请。
尊敬的各位专家教授以及业内精英们，大家下午好，我是新京城传感器的孙建龙。非常感谢呢，这次大会的举办，可以让我们在这里有这个机会为大家介绍我们新京城传感器。同时呢，也非常开心这个时间点，虽然说经过了一整天的这个交流，大家精神会有点疲惫，但是短暂的茶歇之后，相信大家精气神也恢复回来了一点点。我也占据这个机会为大家介绍我们的新京城，让大家更为的熟悉。我们新京城呢是主做力传感器这方面的一个实业制造企业，集研发、生产、销售、售后为一体，去面向我们的客户群体。接下来呢，根据这份 PPT 为大家介绍一下我们六维力传感器是如何助力 AI 智能机器人的高速发展，也希望可以通过这一场会议让大家更为熟悉我们新京城传感器，也更为熟悉我们传感器在工业上，在这个机器人赛道的一些应用。本次汇报呢分4个章节，从公司的概括、核心的技术以及产品的介绍跟应用案例去作为4个章节的一个区分。先从公司的一个概括开始说吧。我们新京城传感器呢是在深圳总部，然后目前员工大概280多号人，占地面积的话12000平，包含今年新增的一个2000平的一个全自动化生产线。我们主核心的力传感器应用，大部分其实是在工业端、3C 制程端以及新能源制程这个车间现场会应用的比较多。在目前人形上面的应用呢，也是大家比较聚焦的。其数据的一些产出，目前反响也是比较好。然后我们目前是全球率先推出最小尺寸的1面式六维力传感器，也是国内唯一提出基于 MEMS 原理的六维力传感器，并将实现自动化量产的企业。一些公司的高新技术资质啊，以及一些ISO 的一些证书，跟我们一些比较特殊的荣誉，就给大家简单的看一下。主要这个29年开始到18年是公司高速发展的一个阶段，深耕在3C 制程以及一些生产线上，去广泛应用我们力传感器。通过力传感器的加装、接触式反馈受力，去保证产品的安全生产。换算过现在的一个人形赛道的话，就是保证加装了传感器之后，有一个高精度的数据反馈，去维护、维持机器人的一个使用工具也好啊，或者说保护我们作为被执行对象的一个安全也好。其余19年、21年、22年、23年、24年呢，是我们一直不断推出新品，包含压电式的张力传感器以及这个六维力传感器的产出跟 MEMS 六维力原理的一个构出。其实这张图相信在早上我们的友商在介绍六维力的时候，大家都会比较熟悉。常规主流现在的一个电阻一面式，无非就是大家的一个结构上的优化、算法上面的一个提升，以及6个维度同时出力去维系它的一个串扰误差，跟后端的一个算法补偿，保证我们的数据输出，这也是我们公司4大核心能力之一。就每张图，像前面大家不好意思，像前面大家聚焦的点，其实就在人形的赛道上。就譬如我刚刚所说的，其实传感器的应用广泛，从之前很长的一段时间，它已经广泛的应用在了工业端。加装了传感器之后，它能很好的去监测接触过后我的产品所受粒子状态，通过这个粒子状态去保护 它这个产品的安全生产，包括目前所使用的一些闭环控制啊，或者高速响应反馈，为了提产能，不断的加速生产的一个频次，传感器都能得到一个非常好的应用，并且通过这么些年的一个数据积累，也能更好的侧向提出我们目前传感器的一个性能。在3C 电子，像大家手头上握的这些手机啊、平板啊、电脑啊，它其实每一步生产，包含组装，它都离不开这力传感器。因为像视觉定位，它只能保证产品到达工位，但是具体压到产品之后，产品当前的状态是怎么样的，它只能通过这种力传感器的加装去保证它当前的一个受压状况。通过粒子的精密反馈，我可以保证每一个产品它都在它的一个需求粒子范围以内，以至于我们现在大部分去买手机，基本不会担心说，哎，拿到手它就是一个有瑕疵的或者坏的，因为每一道工序它都经过了种种的考验，包含我们视觉的传感器啊、力的传感器的这些介入，基本良率到达市场，不说99.8%。但99.5%肯定是没有任何问题的。然后，汽车新能源的一些电信制程，它都离不开这种传感器的介入，因为只有加装了传感器，才能更好的保证产品接触程度，通过这个接触式力反馈去实时保障产品的安全产出。所以我们深耕这么多年，服务那么多厂商，从最早之前的一个单维粒子的一个产出，到后续需要多个维度的粒子介入的时候，我们去研发出这种6维力传感器。其实最早之前，国内首批提出纯硬件结构的这个6维力厂商，也就是我们公司，是最早提出这个产品的。在大家都做出这个产品之后呢，我们又更新迭代，做出了压电式原理，包含目前大家比较关注的 MEMS 原理，工艺的不同介入，能保证不同产品、不同原理它的不同数据产出。只有不同的这种多样式的产品，才能精准的找到客户需求，通过精准定位，保证客户的一个使用性价比。这是我们公司最核心做的，也就是我们最想成为的一个就是一站式利空解决专家。一些自主知识产权的一些专利，然后这个是之前科研专项的一个喜讯报道吧。最主要的还是产品介绍这一方面，希望可以通过这些内容让大家加深传感器的一些应用，以及熟悉我们新进程传感器。我们目前主涉及的几个板块呢，是分为覆盖3C 制程、汽车制程的一个侧力传感器，以及新能源制程的一个张力传感器，还有压电原理就高频响应的这个压电传感器，跟多个维度同时反馈，大家经常听到的6维力 XYZ 跟这3个力方向的一个力矩构成的6维力传感器，跟这个动态扭矩传感器。随着科技的进步，其实已经从最早之前的人工制成车间，跨越到了现在的智能化车间，到后面肯定会进入到无人化车间。这也就是传感器加持之后，它能保证每一段工序它的一个正常运行，通过数值的反馈能保证每一个产品它的安全产出。像最早之前我们经常讨论的是学习不好，后面可能只能经常打螺丝了。但是这个动态扭矩传感器，它的一个核心针对的使用现场就是打螺丝。就说难听点，到后面传感器的一个广泛应用，可能最终打螺丝都不需要人了。科技的进步在于可以解放我们人类的一个劳动力双手，不需要我们再去做这些枯燥繁琐的单工位。传感器的介入呢，能保证每一段工序、每一个动作，它都至始终如一，它都能符合标准以内，去保护这个产品的安全产出。最主要的还是为大家介绍我们6维力传感器，这个是我们的一个产品矩阵，也就是我们的全家福。这个6维力传感器呢，我们含6个最，产品结构最全，有中空的， 可以方便过线，侧边出线的，以及自带紧箍螺钉的，可以直接加装在机械臂末端，等等，很多种，就根据不同的一个需求，有很多种种类去贴切的应用。然后尺寸的话也是覆盖最全，从最小的一个9.5毫米，也就是所谓比这个小拇指头再小一点点，到最大的400毫米，量程从最小的一个5牛到500千牛，力矩方向是0.1到20千牛米。信号输出的话，有内置式集成的串口，也有网口。然后原理的话，目前主流的是电阻翼面式，还有根据客户需求的一些电容式的跟 MEMS 的等等。一直在听电阻翼面式、电容式、石英压电的或者 MEMS 原理，它们到底有哪些不同？可能大家都会比较好奇。但基于这个使用过程，我们可以简单的为大家介绍一下。像传统的电阻翼面式，它就是走一个金属形面嘛。然后目前的优势也好，劣势也好，相信大家经过这么一整天，也都是了解的会比较贴切了。但是我想说的就是，不同的一个使用场景，它肯定会涵盖不同的一个原理在里面。比如说，你需要高频响应的时候，传统的电阻翼面它的一个响应速度就不够了，它就需要上这种石英晶体的去高频响应释放电荷，去保证当前的一个姿态动作，以及 MEMS 原理。这 MEMS 原理的话是采用一项叫硅微熔的一个技术，它对比常规的电阻翼面式有更高的刚性、更高的响应频次，所以对照目前的一个使用上来说，会更符合的贴切目前的一个需求。而且 MEMS 原理呢，也是最有可能实现全自动化生产的一个传感器。像现在目前传感器，它在制成过程中需要耗费大量的人工耗时，需要人员去画线，然后贴片、组桥，每一段工序它都因为手工制成需要耗费大量的时间。但是今年我们这个全自动化生产线的一个铺排，将可以大大的解决掉这个交付的一个痛点，进入到一个全自动化生产的一个模式，去提高我们产品的一致性以及稳定性。由质量管理系统来说的话，目前公司 ISO 9001或者14001这些资质都是符合的，而且部分产品也是为了迎合客户这边的需求，去做了 CE 的认证跟 UL 的认证。然后研发设计这个团队的一个构成的话，也是我们的一个强项之一。280多号人里面有差不多25%都是我们的研发所构成，分为1、2、3步。1步是对于传感器本体的一个研究，2步是对于仪表后端输出的研究，以及3步是力控包软件的一个研究。生产的一个过程的话，我们也会导入一些QC 巡检啊，或者 IPQC 出货以及来料的一些管控制程，去保证我们产品的品质。至于这个测试跟检验设备，我相信家家都有拿得出手的一些设备以及它的一些应用，所以就大概说一下，提一嘴就可以跳过了。然后我们目前总部像刚刚所说的是在珠三角深圳这一边，然后深圳、惠州以及香港这边是设立了一个生产区，然后北京跟苏州是办事处以及不同的一些终端网点。多点办事处的以及网点的铺排呢，是为了更好、更快速的去响应我们客户线上以及线下的需求，可以做到第一时间，我回答客户的疑惑，然后解决不了客户电话线上的问题的时候，可以快速的到达线下位置去服务客户。最主要一些应用案例的介绍，可以让大家在了解我们新性能传感器之余，可以看看，目前我们一些应用是大致是什么类别的。像人形，大家今天听一天，手腕的、脚腕的，做这个力的软件控制也好，姿态补偿也好，它都是很好的作用在人形本体上的。加装了传感器之后， 可以使机器人更为稳定的去做这些动作啊，包括它的一个自由姿态行走啊，这都是得益于传感器的一个数据反馈，让设备更加智能，让机器人更加的有感觉，这就是我们力传感器的一个妙用。像市面上现在很多协作机械臂也好啊，或者说人形也好，它大部分应用就是在关节处的一个关节扭矩的一个数据产出，以及末端的一个6维加持，去保证动作的执行，保证它的一个姿态平衡。加装了之后可以做防碰撞啊，以及姿态修正啊，或者拖动视效啊，种种不同的应用，得益于传感器的一个数据产出。这样人形的家可能人形的样子都不太像，但是应用家都差不多，所以可以看一下这个关节扭力以及6维手腕、脚腕跟0小手指间。这个视频呢是为大家展示我们6维力传感器的一个灵敏感知程度，以及目前我们做的一个最小的9.5毫米，它的大概小是小到什么样式。这是一些客户终端的一个使用情况吧。加装了之后，手腕上面的一个加装，包括手臂连接跟脚腕的这个加装。脚腕的加装的话，除了力的一个呈现，它也可以拿来做姿态的一个调整。像目前刚刚所说的，低空经济啊，或者说这个常规的姿态修正这些传感器，它具体的应用其实就加装了传感器之后，它可以很好的分辨 XYZ 或者 MXYZ 的一个力值呈现。通过不同维度的力值呈现，我可以去实时的修正它的姿态，保证直上直下它的平衡，不那么容易跌倒啊，或者说摔跤。所以更多的我们在面向传感器或者机器人的时候，担心的点都是说，这种电子元器件会不会失灵啊？会不会因为碰到水之后，就像别的这种电子设备一样失灵啊，或者说故障？我们针对这一些，其实做了大量的测试，包含目前最高的 IP67甚至到 IP68的一个传感器的面试，它就能很好的去展现我们传感器的一个防水能力，以及各项的一个 PPT 内容展示，很好的呈现出我们的一个灵敏度。因为大家如果面向一个大铁块向我们本体走过来的时候，肯定是会畏惧的，会害怕，担心它会伤到我们。但是加装了传感器之后，可以看到一个锥头触碰到传感器，它都能很好的反馈当前的一个力值反馈，去做到动作的止停，连气球都不会爆。那我们人是不是可以得到更好的一个保障呢？像防水的一个测试 IP67，然后按摩过程中加装这6维力传感器，它都是目前一些比较主流的应用，包含工业端的一个拖动视效啊，或者说马舵啊、抛光打磨，它都是加装了力传感器之后，它有一个比较好的呈现。在打磨过程中，可以通过力值的反馈去做闭环、多退少补，保证我们的打磨效果。在按摩过程中也是一样的原理。但是就像刚刚说的，其实大家在面对这种比较新兴的东西的时候，总会害怕。我担心这个按摩机器人会不会失灵，直接一下把我按到骨头断掉的，或者说担心这些伤到就是失灵的时候快速直接打到我们人本体的。其实它这方面的顾虑总是会非常非常的多。但是工业品的一个设立，包括它的一个快速发展，它做了非常多的保障。视觉的定位也好，力学的一个实时反馈也好，它都是为了唯一的核心点，就是服务于人类，保护我们作为被执行对象的人类。所以科技的进步的同时，我们可以更好的去享受，更好的去让自己双手去解放，不需要苦于之前的一些繁琐动作，让我们亲自参与进去。加装了这些传感器之后， 他们可以更好的使用工具，帮我们去解决这些异常也好啊，或者使用场景也好，这样的话才是能大大解放我们双手，恢复我们自由，才是科技进步的一个重点。后面这些都是我们跟不同厂商的一些使用案例介绍，包含刚刚所说的一些打磨，以及焊接的、拖动视效的。只是最早之前的拖动视效，它更多的是应用于坐标点的一个建立，它整体的一个工作量就非常的繁琐。但是加装了传感器之后，它可以实现力牵引，去快速生成它的一个所需路径。所以这也就是为什么我一直在强调科技进步的一个红利。只有这么不断的去研究出各种不同的场景，那样我们才不需要苦于这个场景的一个囚禁吧，就可以完全解放我们自己了，就不需要再去做这么枯燥的、这么繁琐的、这么劳累的工作，一切都可以交由自动化设备，或者说机械臂，更或者说人形机器人。一些协作上面的合作客户的展示，其实大差不差，因为市场的需求摆在那里，大家都可以去完善自己的产品，去做好、服务好这些客户，以及一些人形的。像我们最早接触的就是工业端，也就是果链的制程。这也是为什么一开始我会跟大家介绍的时候就说，大家手头上的这个手机也好啊，平板也好，其实传感器早已参与到了我们人使用的不同器具的任何生产过程当中。只有加装了传感器，它才能更好的保证这类产品的安全产出，更好的保证被执行对象的一些安全。我们公司呢，最主要的一个使命呢，就是赋予机器力控触觉。然后我们的愿景呢，是成为力学传感器行业的一个全球领先品牌。我们的价值观呢，是以客户为中心，以贡献者为本，品行端正，学习改变。至于4个坚持，无非就是让自己做得更好，管好我们的品质，管好我们的产出，让客户、让终端使用的更加的放心。好，这是我的本次汇报，也就是加速助力 AI 的这个会议主题。好，感谢大家。
谢谢孙金龙先生带来的精彩分享。接下来，让我们欢迎深圳市美思先端电子有限公司市场总监沈苗女士，她将为我们带来 MEMS 传感器创新技术与应用的演讲。掌声欢迎沈苗女士，有请。
好 ，OK， 尊敬的行业专家学者，还有各位行业同仁、女士们、先生们，大家下午好。我是深圳市美思先端电子有限公司的市场负责人沈苗。今天呢，我将围绕 MEMS 传感器创新技术与产业化应用，来为大家做简要的讲解。美思先端呢是在2015年呢创立于深圳光明。那我们是一家专注于 MEMS 传感器领域的科技型企业。目前呢，我们聚焦的是红外测温和红外测气领域。那我们目前采用的是 IDM 的商业模式，是集芯片设计、制造、封装、测试、营销，还有终端应用等多个产业链环节于一体的一家科技型企业。那历经10年的发展呢，我们从为客户提供光学组件、红外热电堆，还有红外热释电的传感器探头，逐步成长为可以覆盖终端应用模组及行业解决方案的一家创新型科技企业。 这个是我们的团队成员。那经过10年的发展呢，目前呢我们产品的覆盖能力上面，目前是我们拥有6大产品体系，是有气体、有温度，然后有粉尘、有压力、有流量。还有我们的光学组件，也就是中远红外滤光片。目前的话，我们是覆盖了有70多种 MEMS 传感器，还有150多种型号的精密光学组件。那在硬件实力上面呢，目前呢，我们是拥有1万平的洁净厂房，那拥有7条专业的产品线，那有我们的光学组件，有压力，然后有气体，有温度，还有包括我们的粉尘流量。然后我们是在近3年呢，逐步搭建起我们的 CLAS 实验室、莱茵木基实验室。这一部分呢，主要是为我们的产品品质，然后提供了非常有力的保证。然后目前其实我们的应用主要是覆盖家电和汽车领域这一部分的产业化应用，我会在后面给大家做详细的讲解。然后经过这10年的发展呢，目前其实我们整个的产品层次其实是有3大板块。那第一大板块是围绕着我们的光学组件，就是我们的中远红外滤光片，还有包括我们的红外光源，然后还有包括我们的红外热电堆、红外热势电的探头。这一层是我们的底层共性技术体系。那围绕这个底层的共性技术体系，我们逐渐搭建起了我们的空气质量、工业安全，然后包括我们的车用传感器的终端应用模组的板块，然后再基于这2层产品技术架构，我们又逐步搭建起了我们的终端产品，还有包括我们的一些相应的实验室设备的这一系列的3层产品体系。那主要是可以满足我们整个产业链上中下游不同企业的多样化需求。在核心技术这个板块，其实主要目前我们聚焦的还是红外测温和红外测器。那我们基本上是已经实现了我们的光学组件，还有包括我们的芯片，还有我们的算法，还有包括我们终端的这些模组，基本上我们是实现的一些全覆盖。那在温度场的温度测量这部分的话，目前的话，我们的红外热电堆阵列技术其实是打破了海外的这个垄断的。那值得一提的是，目前我们在红外热电堆阵列的这个板块，我们目前处于批量化应用与迭代的阶段。相较于大家熟知的这个制冷、非制冷的这个红外传感器，在一些民用领域，那红外热电堆阵列传感器在产品成本和性能方面，它是拥有一定的优势的。在高精度气体的测量的板块，那我们目前是拥有红外气体传感器核心探测器的产业化能力。那基于我们的光学组件，主要是我们的窄带红外滤光片。还有包括我们的红外热电堆、红外热势电的传感器探头，我们搭建起了我们的二氧化碳、甲烷、6氟化硫、火焰、冷媒传感器的产品体系。那同时呢，就是基于我们的 IDM 的商业模式的这个优势，我们扎实的产品底层共性技术与硬件条件，那每次先端具备更有效的大规模的这个成本控制和产品交付能力，获得了汽车还有家电领域多个头部厂商1级供应商的认证资质。这个是我们在近5年来，然后获得的比较有成就性、比较有里程碑式的意义的一些成就。那接下来呢，我将给大家简单介绍一下我们的传感器产品在家电和汽车领域的相关的产业化应用。这部分是我们的家电传感器产品的一些相应的应用案例哈。首先呢是在空气净化设备领域，目前的话就是 我们的二氧化碳传感器、我们的粉尘传感器，目前在我们的空气净化器，还有包括空调，还有包括空气质量的这个监测仪方面应用的是非常的广泛的。然后在冷媒的泄漏，在冷媒泄漏监测的这个板块，那提到冷媒呢，可能大家熟知的冷媒就是氟利昂了。那哈弗制冷剂呢，在就是自20世纪30年代以来呢，发展到现在共有4代的这个产品。自1987年的蒙特利尔议定书以来，1代产品已经是淘汰了，那2代已经进入了淘汰期，那3代呢，在中国已经进入了生产和消费的冻结时期，4代目前处在成长期。那冷媒的安全等级呢，又分为4个等级，一个是无火焰传播、低易燃、可燃和易燃易爆。易燃易爆4个等级的易燃性。目前市面上很多空调所应用的制冷剂都是弱可燃这个等级。那我们的传感器主要是用来实时监测冷媒泄漏的，进而呢为人们的这个生命和财产安全呢保驾护航。目前大家熟知的这个ARL 的制冷剂有 R32、R410A、R454B 这一些哈。那在家电应用的板块呢，在家用微波炉这个板块，普通的这个家用的微波炉呢，它对食物的这个加热，其加热的时间呢，基本上都是根据个人的这个经验或者喜好来进行设置，它并没有办法实现呢这个加热温度的准确控制。那我们的这个红外热电对阵列产品，就是我们的这个 MTP-A 这款产品呢，它可以精准的对于食物的表面进行全部覆盖的这个温度的监控，进而实时的去控制我们这个食物的加热的精确的这个时间和温度设置。这个是目前就是在家电这个板块应用的一个大方向。在同时呢，我们这款 MTP-A 的红外热电堆阵列产品呢，在燃气灶这一部分，它的应用也是非常广泛的。那厨房的燃气灶应用的是我们的这个红外热电堆阵列传感器呢，它是装载在这个抽油的这个下方，它可以实时的去监测我们灶台的这个温度场的分布，它可以精准识别这个异常火焰的这个，进而我们关闭，这是讲的无论说是我们常用的这个家用空调，还是说儿童空调，那动态的去控制我们空调的开或者是关，这一部分呢就是我们在空调这个板块的应用。在跌倒检测这部分属于居家养老这部分，那有很多的独居老人，在独居老人的这个领域呢，就是我们 MTP-A 的这个红外热电堆阵列传感器呢，它可以实时监测人体的这个姿势和动态，进而得算法来去识别人员是否有跌倒，进而通过信息传输，并且实时的去进行预警、预防呢，就是有一些就是老年人的这个生命安全对一系列的保障。那下一个板块我将简单跟大家介绍一下我们在汽车领域的相应的一些产品的应用。在汽车这个板块，我目前的话主要是5大方向。第一个方向呢是我们温度场 温度场分布测量的传感器。那这部分呢，包含了我们的车内的活体感知，还有座舱空调的控制，还有包括我们的电池的温度的监测，还有包括高压充电桩温度在线的监测。那同时呢，还有包括我们 NDIR 气体的这部分的监测。那一部分其实它也有，它也有我们车内的这个活体的，包括我们的粉尘，还有包括我们二氧化碳的浓度，还有包括我们锂电池失控的相应的释放的一些气体的监测啊，同时还有包括目前在欧美领域应用的比较普遍的我们的酒精的监测。那同时在空气板块还有我们的这个 AQS 的空气质量的传感器，同时还有我们汽车粉尘的传感器。那同时呢，还有我们的这个压力的传感器啊，目前主要覆盖的是这5大板块。那在座舱的这空气质量这部分呢，大家都知道，无论是在室内会议室，或者说是教室，或者说是密闭的这个座舱里面呢，你的时间一长，那你的二氧化碳的浓度，那它会逐步的上升。那如果你经过你的车辆驶过污染较重的领域，你在进行空气的这个内外的自动循环的时候，你会将外部的污染物也带入到你的车内。那我们目前就是研制了二氧化碳传感器，我们的粉器，还有我们的3合1，也就是集合了我们的二氧化碳、粉尘，还有 AQS 的，还有包括我们的2合1传感器，也是集合了我们的粉尘和二氧化碳的传感器。它最终呢实现的就是我们的粉尘的浓度，我们二氧化碳的。还有包括我们的一氧化碳、氢内、氨气等一系列的这个有害气体或有害气体的一些监测，进而进行一些实时的这个空调的，还有包括座舱内部的、内外部的一个正常的一个循环这样的一个一个功能。那同时呢，还有包括我们目前的二氧化碳传感器，它还具备的一个功能就是我们的，因为目前有一些车用的冷媒的传感器用的是R744，那它最终形成的气体其实本质上就是二氧化碳，也就是我们目前热泵的这个应用领域。那目前其实这部分有一些车用的厂商也是在逐步的在跟我们去做一些合作和相应的应用。那车内的活体感知，这部分刚才我有提到，主要是2个方向，一个是通过我们气体二氧化碳，来去监测、去感知我们车内是否有生命遗留。然后第2个其实主要还是围绕着，就是说通过我们的 MTP-A 我们的红外热电堆阵列传感器，它通过对车内的活体的体温感知检测，进而去进行实时的预警的这样的一个机制，来去避免导致有一些，比如说可能有的人你在车内密闭久了，或者是中午在里面午休的时候，有一些人他会就是说导致有一些情况是，比如说一氧化碳中毒，或者说是有一些浓度过高，比如说你的小孩或者说你的宠物遗留在你车内的时间很久的话，你的浓度升高，或者说是大夏天你的温度很高的情况之下，那它会窒息而亡。所以本质上而言，它更多是防患于未然的这样的一种检测啊，保证我们司乘人员的这个生命和财产安全。这一部分呢是目前在汽车领域应用的这个发展趋势，主要是在我们这个新能源汽车的这个驾驶的这个智能的一个方向。那比如说我们空调的这个感知的话，那如果它装载了我们的 MTP-A 红外热电堆阵列传感器，那它其实是可以通过非常精确的算法来去识别你车内你具体坐的位置，然后你人体的温度，进而去实时的去控制我们的这个空调的温度，还有你出风的这个方向。目前的话，我们的热电堆阵列传感器目前是在这个方向，可以去辅助我们众多的这个车厂去迭代它的这个智能座舱的一些功能。那在汽车热泵冷媒泄漏监测这部分的话，目前整体应用的大方向呢，更多是倾向于环保的 R744和 R290。那 R744刚才我提到了，它成分主要是 气体主要是二氧化碳，那R290主要是丙烷。这一部分呢，就是目前的话，其实我们也在跟国内的一些头部车企在做一些联合的技术攻关和合作，然后尽量的是说装载就是车载的领域，你用到我们这2款传感器之后呢，实时的去监测我们冷媒是否有泄漏，你泄漏浓度是否达到你的预警值，进而呢去保证我们司乘人员的一个安全。在电池的充放电安全的这个监测方面，那储能电池呢作为电力储存和释放的这个主要设备之一，那它存在着这个过充放电的这样，就是在储充放电过程中的这个温度升高的这样一个现象。那温度升高呢，你就会导致电池内部发生膨胀力的变化，严重时可能导致电池损坏或者是甚至是爆炸。那我们 MTP-A 的这款热链对阵列传感器呢，它可以对你整个这个储能电池的表面的这个温度实时去做监测。然后呢，如果你一旦出现了这个过充或者说温度过高的这个情况，它会进行呢实时的这个提示，然后通过你的主控去做一些的预警，这样呢避免我们的这个电池充放电的出现一些就是爆燃的这样的一个情况。好，整体就是目前的话，我们的传感器还是应用在呢家电和汽车的这个领域，但是我们同样也期待在未来能够在机器人这个领域能够和就是全球的厂商有一些联合的技术攻关和开发，并且合作。这些呢就是今天就是主要的主旨，主要是给大家讲解了这一些。那同时也欢迎大家有空的时候到访我们美思先端，交流合作，勇抓行业发展的新机遇。谢谢大家。
感谢沈苗女士的精彩分享。接下来我们邀请的是斯法克斯大学教授 Rames Malay 上台，他将为我们带来主题演讲，用于超灵敏和选择性生物检测的先进2D 纳米复合材料。掌声有请 Rames Malay。Let's welcome Professor Rames Malay。有请。
Thank you very much for this occasion to present my latest research in to this consortia of companies and researchers all over the world, and also for the stakeholders. You know that any advances in sensor physics leads to a lot of and huge advances in robotics and capabilities of detection of materials. I am basically I am Ramzi Maalj, a physicist and specialized in nanotechnology. I am leading research team in University of Sfax, and from 2022 I founded my startup, which is a Fluink Nanotechnology specialized in advanced and designed nanomaterials. So today we will discover together the work of my PhD student, which led to advancement of here. Okay. And I will speak to the advances of new sensor based on chemical sensor for detection of biomaterials, and especially to challenge us to solve many problems related to food safety and environment monitoring for detection of carbon footprint, and to monitorize and the water quality, and especially many countries encounter the problem of water scarcity. And I'll speak and focus today on the medical use of such sensors for detection of certain diseases. So the reliable and rapid analysis of technologies are crucial to meet these urgent challenges. So the conventional methods of chemical detection are time-consuming and expensive, and as well are specialized equipment and skills needed for such sensing. But however, the chemical sensors are relatively simple and real-time tests who offer also cost-effective measurements and easy to use. So there is 3 layers of such detection from the analytes that we will want to detect through the receptor, which is the molecular recognition, and the transducer, which can be optical, thermal, but we will focus on electrochemistry detectors, which give us the signal can be transformed as data, which we can be analyzed by, let me say, machine learning and artificial intelligence. Though the performance of the sensor, such sensor can be tested through its cell sensitivity, selectivity, response time, and reproducibility, and lifetime as well. Such conventional chemical sensor offer us real-time monitoring, easy to use, continuous monitoring, and portability and miniaturization. So from the practical point of view, the classical electrochemical cell is composed of 3 electrodes, which are related to potentiostat. We use in our laboratory advanced screen-printed electrode, which will act on the material size and the material's surface, which is called the active surface for detection. So from the measurements that we see here in the diagram, we can extract the reversibility, the redox behavior, the transfer resistance, and absorption of or diffusion, which are quite important to determine the quality of the sensor. For this aim, we adopted the 2D materials as graphene, as also transition metal decalcogenized, MXN also, I will show in my study here. And this is on the goal to enhance the sensor sensitivity, to achieve faster response time, which is quite important. Second, to reduce the interference from other spaces when there is interference, where there is other lot of biomolecules, and increase the electrochemical stability. So enable detection at lower concentration, which is our basic goal, and to extend sensor lifespan and reusability. So in our laboratory, we are able to manufacture and to produce 2D materials because they offer certain stability under many conditions and large surface to volume ratio, and especially scalability and manufacturability. And this is the goal to reduce their cost. So the synthesis, we are interested in 2 families as carbon-based materials, as graphene, for example, and carbon nanotubes, and the transition metal decalcogenized. So as you see here, this is the electrode and the surface, round circle surface, which is the active, and we are modifying the surface in order to reach the goal of high sensitivity, especially at very low concentration, in order to detect some biomolecules which are biomarkers of certain diseases. So the electrochemical methods used here are voltammetry and differential pulse voltammetry, impedance spectroscopy, and also clinoperimetry. And the target analytes presented today are 2 analytes due to their importance in presence their presence are very significant because for the first target is the dopamine, which is involved in the experience of pleasure and often associated with the brain reward and system. The second is the lactic acid, which is associated as a biomarker in certain disease as cancer. Our objective is divided in 3 steps. We elaborate and prepare the 2D material in our laboratory. We deposit it to functionalize the surface of the electrode, and finally to test, to make extensive research, extensive testing of the quality of the sensor in order to prove the improvement. So here we fabricated a new nano composite, which is the combination of nickel oxide coated carbon nanotubes, and was subject of publication, appeared recently. And when, after deposition of the layer of new nanocomposite and the electrode, we explored its capability for the detection. So the presence and the adherence between the carbon electrode and the nanocomposite have been successful, and there is adherence between these components. Then the property of electrochemical behavior have shown here more reversible and especially faster electron transfer, which is quite important for any sensor property. So there is a beneficial role of the nanocomposite in enhancing the electrochemical response of our sensor. From the point of view of electrochemical characteristics, we expose it to many testing, voltammetric testing, and we, in order to optimize the best condition of the testing of such sensor. And we approved that improvement of its properties and this functionalization. We tested also the number of cycles and which each impact on the measurement, and we obtained that there is a high sensitivity when we applied 200 cycles with the drop of deposit of 40 microliter, which is the best condition, and also the potential of 0.5 volt. So to determine the sensitivity, here we present the calibration curve, and as shown in the table, 2 tables here, that the high sensitivity of our sensor, and especially the low limit of detection, which is at the order of lower than micromolar, which is quite good when compared to many studies and many commercial sensors. So the repeatability is a crucial factor. So we obtained excellent repeatability, and then we tested the interference, which also important when in the presence of many species, and the signal shown that there is high selectivity of the lactic acid even in presence of a complex environment. So as you see here in this table, we tested the reliability of our sensor, and it is shown high reliability and very promising for to be applied in detection of lactic acid in hospitals. The second case illustrates that the new nanocomposite, which is the combination of ketosane with molecular diselenide, and was the subject also for a new article. And we chose first the molybdenum diselenide because it's semiconductor behavior and tunable properties. It's easily to prepare in laboratory and large surface to volume. So the ketosane is a biocompatible polymer that can be obtained from shrimps or maybe scraps, and it has good adhesion and electrochemical activity. So the preparation method of nanocomposite is well dominated in the laboratory, and we have characterized and according to many criteria the new sensor, and we obtained good adhesion and the very good properties, and this is the fruit of 3 years of extensive research, and we determined the best condition of application of such sensors, and here also the second case shown very good sensitivity as we expected, with very low limit of detection, lower here than the micromolar, which is quite important for precise medicine and precise analysis of biomolecules in blood or in saliva. Here you will see clearly that excellent repeatability, which is important, and with good reproducibility of the signal, even when you use different multiple use of the electrodes. Here, the real sample analysis, we analyzed blood serum and saliva, and the detection have been well reliable and well compared to the expected. So these advances in electrochemical detection will lead of new perspectives and open also new application, especially in robotics, and will empower new robots with new sensors. As you have seen here, there is a lot of advances when we are speaking about new capabilities and new sensors, and which empower the robots with new, let me say, skills to detect here diseases at very early stages, and give us the potential to stop these diseases. And when combined also with artificial intelligence, it can lead to results to prediction of some models, and to predict the effect of such sensors in detection, and go lower and lower. And this is very important, not especially in medicine, but also in forensic science, to detect some crimes, or maybe for in other fields in environment. All this work have been developed under the sponsorship of Fleoink Nanotechnologies, which is my startup, founded in 2022 with 4 scientists, and we are collaborating with companies to develop new R&D activities around nanotechnologies, material science, and we developed recently new products of antibacterial which can protect us from any further pandemics, and especially from nosocomial diseases which are living in hospitals and clinics. This is my presentation. Thank you for your attention.
感谢 Rams Malay 教授的精彩分享。通过他的讲解，我们不仅了解到了先进2D 纳米复合材料在高精度生物检测中的应用潜力，也深刻地感受到了斯法克斯大学在纳米材料与功能传感技术研究方面的领先实力。接下来，请意法半导体的 Alan Lagaska 先生上台，为我们带来加速智能传感器在机器人领域的融合。掌声有请 Alan Lagaska 先生，有请。
Good afternoon, everyone. I hope everyone's still okay after a long day listening to a lot of stuff. I'll try to make it as, let's say, entertaining as possible to keep you awake on this. So I'm taking care of robotics in terms of strategy in ST, and really thankful for the organizers for inviting me for this event. Okay, so let me start in introducing ST. And ST Micro is one of the companies had invented, let's say, BCD technology. So practically we say we are the creator, one of the largest semiconductor company in the world. We are Italian-French company, but we do a global footprint in many locations. We do invest in many locations, as you can see in here. We have global presence in terms of R&D, manufacturing and sales and marketing, both front-end and back-end manufacturing. So just start with on technologies and product. We have actually quite a wide variety, and of course the event is related to sensors, so I will try to narrow down on sensors, but just to give you an idea on the technologies that we have in ST. And we do have MEMS technologies, power devices, in CMOS, BiCMOS technologies, and different types of optical sensing that is relevant for this event. So our products and solutions basically cross different applications from automotive industry, industrial, medical, and of course in these applications for robotics, our MEMS optical sensing technologies are most relevant at the moment. So I'll try to narrow down further on the MEMS in terms of the scope. So most robotics application today are and needs motion sensors as well as optical sensing solutions. But we see also relevance on other sensors that we offer, like environmental sensors and micro actuators. That is also helping in terms of the evolution and development of most of the robotics today. Okay, so narrow down on the humanoid robot. Okay, so these are some of the products. So I'll try to put it at the same time. We have time of flight sensors. This is basically a light technology to measure distance, and image sensors technology that is used as well in a variety of in a practical application for humanoid robot for vision positioning, as well as ambient light sensors. These are also the products that we are also pushing forward, not only for humanoid robot, but also for industrial robots and different kind of, let's say, environmental related or sensing related applications. These are for MEMS sensors for humanoid. We do have both industrial grade, automotive grade, because some companies developing today for humanoid robot are also coming from automotive companies or new ones that are more industrial related ones. Both of them today, we do have these kinds of technology in ST. Use cases like navigation, distance measurement, stability are the most that are being used. And it also comes with a full ecosystem that we provide as well. You can get all these informations in our website in order to support the semiconductors that we offer. Okay. So I've tried to give you some of the products to highlight, just as a takeaway. So this is our latest product related for LiDAR and 3D modeling. It's very good for room and environment mapping. Again, this is relevant for, let's say, for robotics. You see that why this is also good for privacy-related concern, because in the face are basically not being shown, and this is good when you do a roam mapping and or when you add this for, let's say, object or gesture detection recognition, and keeping as well the human privacy portion. In terms of mapping as well, we do have ITOF sensors for humanoid. This single sensor can cover 2 use cases, either low resolution or high resolution. Again, applications related to robotics is quite high on this product. What I'm showing to you, these part numbers are basically the latest ones that we are offering related to ITOF. Okay, and as we also evolve in terms of sensors, IMU is needed for high accuracy, stability, as well as, of course, there is a need for adding more integration of AI. Okay, so I mean, it's not just having a separate microcontroller. We are integrating more intelligence inside our sensors. So these sensors are actually programmable. You have a machine learning core inside where you, without having the need of a separate MCU, these sensors already are basically what we call intelligent, more intelligent sensors with processing unit. Okay, so these are also evolutions in semiconductors where ST is investing. Okay, and in order to support humanoid robot or anything related to robotics, and particularly for sensor technologies. In terms of strategy, I'd like to show you as well in terms of segmentations of robotics. So we look at robotics in modules. Today, most of the humanoid robot makers are buying different modules from the head unit, articulation, which is more on the motor control portion, main processing, communication, connectivities. Each of these are today coming as parts. And with different companies supplying these, sensors basically are everywhere. Okay, so when you go at the head unit, most of those are camera sensors. When you go to the articulation part or the motor control, there are IMUs needed for the positioning. And of course, in terms of navigation, you need to understand where you are. And in terms of mapping, so the products that I was showing to you, like ITOF or the ALS, or also for the IMUs that we are providing, these are very much relevant for navigation, but it's also very much relevant for stability for biped, especially for biped humanoid robots. Similarly, we also cover in here different domains. Today there are no specific standards for the voltage domains in humanoid robot, but just to give you, let's say, an overview that we can basically cover different types of voltage domains requirement for humanoid robot. So this is how we are, let's say, enabling physical AI today for humanoid robots. In terms of sensors, in terms of power, in terms of actuator, practically these are areas today that ST have, and also what we call distributed brain, which is the micros that is running the motor control or the battery pack, or basically the portions related to the sensors. So each of these today are technologies that we offer in ST. At the same time, we are also supporting the ecosystem to support this. We're also looking for partners in order to develop these new technologies, and at the same time understand what is going on in terms of new architectures. And this is part of my activity today inside ST, to understand system architectures that is also next generation robotics. Okay, so I'll try to give you a visual on how we are in ST. So we are also not just providing semiconductors. We are also trying to visually show how semiconductors are in a different technologies. So this is a full automation system. It includes Basically, the process controls. We have the motor control portion. This is a maglev, okay, which is quite good for, let's say, it reduces the noises. But we also integrate a lot of technologies inside and sensors technologies. Like in this case, once the product reaches a certain point, a proximity sensor is there to move the next portion. And if you notice, even the claw is waiting until the product finishes the packaging. So today, we are not just providing a product evaluation board in ST. We are also trying to demonstrate how different technologies of ST combined together can provide solutions and from sensors, power management. We are also providing practical implementations for security and safety. On motor drivers and actuators, these are quite important for for humanoid robot, and of course connectivity plus the edge AI. So how we look at robotics system today is the same way as the video that I was showing to you, which is a full automation system. So in a way, we can break it down into 5+1 core system blocks. So sensor comes in on the top. Today is also related to Smart Sensors Asia. But this is to also outline that in a humanoid robot, practically there's in every joint, you need sensors. In navigation, you also need sensors. So, but at the same time, for ST, we can offer from sensor visualization. It can be a camera module. It can be an HMI. For connectivity and networking, today there's a lot of standards that is coming up. Wired standard normally come with a CAN or EtherCAT or other requirements. And of course, for wireless portion, we do provide as well in Bluetooth, Wi-Fi technologies, even next generation requirements for robotics. Similarly, for actuators, we put it in generic, different actuators for in terms of integration. So we do have products that integrates the microcontroller plus drivers in one chip, or a driver plus power devices in one chip in order to make as compact as possible, as light as possible in terms of miniaturization. And also for processing and control, we do also partner with a lot of software developers, and even we follow as well some IEC standards that is also complementing in China some GB standards in order to have a more, let's say, a common platform for processing control. And these are all supported with AI technologies that is coming from ST, securities as well, that is becoming quite important, especially for European market, like cybersecurity. This is needed, and these are also investments we are putting in ST, plus power related solutions. So to give you a more visual way on how do we address humanoid robots, so from the leveraging on the automation system, we are showing basically also our AI know-how. So on the left side, on the right side portion, basically there's the camera sensor in there, and then the gesture recognition is done by the AI. And this is a small AI, and it's just an NPU, but it's already enough in order to process the data set coming from the picture that is taken by the camera. And we go and process it through our PLC. So this PLC is running on IEC 61131 standard for programming that is in here. We partner with Codesys, and we were able to translate down to a robotic hand. Now, the complexity for this is actually most of the time a software AI is able to come up with a lot of data sets and capture a lot of data sets. But most of the challenges that we find is translating these data sets to different type of standards. So this example gives actually a very visual way of the challenges that software engineers are having when you have 21 finger key points and you're translating this data through different standards like 485 or TUCAN and basically control A15 servo motors. So this is not even a 1:1 comparison between what is taken by the AI data set and managing as well that you don't lose any of the data going through different standards. Okay. So in this demonstration, we are already able to show all the 5 elements related to a robotic system, from the sensor portion and the camera module, the AAI that we are using, which is the STM32N6, the connectivity portion to support moving those data sets to the processing and logic control with our MPU, and translating it to another standard called CAN in order to control the robotic hand. Okay, so again, going back to the challenges that we see today implementing technologies, in semiconductor, we can actually integrate a lot of technologies in one chip. Okay, so it's no longer let's say a problem of miniaturization of technologies or integrating microcontrollers, microprocessors. It's coming down to not only having the software, but it's able to translate those softwares to the language that a automation or let's say robotics is able to understand. Okay. So just of course, ecosystem is one of the things that ST is also trying to support basically our customers in order to develop and use ST technology. And in order for our sensors and our MEMS technologies to be able to be used, let's say, seamlessly for our customers, we also provide basically all these software libraries that is compatible with our STM32 for calibration. And in here also for position tracking. All these informations today are basically available in our website. You can download them. And for, of course, when you are looking at our STM32 ecosystems, this also supports AI. And these are basically the trends we see that helps add value and not just providing new directions in terms of semiconductor integration, adding machine learning cores, or integrating basically, let's say, new functions. But what we see today as an added value to customers is closing the gap as well, that any engineer is able to make use of these new technologies without getting through and reading through the data sheets, but having the models and examples on how to use these new technologies that we are offering in ST. So if there's some interest that you have on any of these products, platforms, or ecosystem sensor technologies relevant for robotics, we are very much interested in partnering with you. Okay. So as a takeaway, basically we are committed to become a leader in robotics for the industrial market. We have quite a good number of technologies, and of course sensors are crucial to make humanoid aware, responsive, capable of performing complex tasks in a real-world environment. And ST Microelectronics today stands out in the robotics sensor market thanks to its comprehensive, high performance, and innovative sensor portfolio. So you've seen as well how the investments we have in ST when it comes to different types of sensors, from IMUs, pressure sensors, time of flight sensors, ambient light sensors, and camera imaging sensor for machine vision. In short, we have a portfolio of motion and vision sensing. Okay, so these are key messages that I would like to impart with regards to our sensor technology, but also one of our target today is also we're seeking for long-term partners in terms of system collaboration in order for us to understand what can be the next generation product looking at the trends. And I really respect as well the presentations coming from our colleagues in here today. I've seen a lot of new areas to explore and possible collaborations that I think semiconductors also can add value, understanding what is going on from other countries, as well as the investment coming from universities. So we do collaborate a lot of universities whenever where we work. Okay, so in Italy we do collaborate with universities in Italy. In France we do as well collaborate in France. In Shenzhen, I also lead collaboration together with our Markham team with Shenzhen University and other universities that are relevant to the, let's say, evolution of semiconductors. Okay, so it's not just, we've gone beyond just having CMOS, BiCMOS, VCD technology. The evolution now is more on basically what else are, let's say, being researched. How can we impart this know-how to universities in order for us to be able to see and also to impart this, that next generation of engineers will be able to also have this reduce this gap. Okay, that this is not just know-how coming from the manufacturing of semiconductor, but also engineers will be enticed as well to invest and understand about semiconductor. Okay, there is, what I see today is there's a huge gap in, let's say, the know-how and expertise in using semiconductors with respect to the investment on software. There's a huge number of AI engineers, but at the end of the day, you need the hardware. Okay, so that's the key area, and without understanding basically the technologies behind the semiconductor that is going to implement the software, you have a gap between the real world and the physical AI, right? So this is why there is a slide related to ST, enabling physical AI, okay, in the real world. At the end of the day, whatever we do on the software, it has to come out as physically and useful in this case. So again, just to move to the last portion, we are looking for partners. Okay, we are looking also for system collaborations, and ST is committed as well in this market. Okay, thank you very much.
感谢 Alan Lagaska 先生的精彩分享。意法半导体作为全球领先的半导体与传感器解决方案提供商，长期专注于高性能传感器、微控制器及系统集成，凭借着卓越的研发能力、丰富的产业经验和全球化的网络服务，其技术在工业自动化、智能机器人和消费电子等多个领域得到了广泛的应用。这一次的分享呢，不仅呈现了技术应用的落地经验，也展示了企业在智能化赛道上的战略思考。 为在场的从业者提供了宝贵的参考范本。让我们再次感谢 Alan Lagaska 先生，谢谢。非常感谢各位嘉宾在论坛中的深度分享与精彩的讨论。至此，2025亚洲机器人智能传感系统应用大会第2天下午的议程就圆满结束了。感谢各位嘉宾和与会人员的积极参与和支持。未来智能传感与机器人产业仍然将保持着高速创新的态势。我们期待大家能够继续聚焦行业机器人智能传感领域，与我们一同推动产业迈向新的高度。同时，也向大家发出诚挚的邀约：明年的6月24日，亚洲智能传感器与应用技术博览会将会在深圳福田会展中心3号馆如期举办。届时将汇聚更多的行业资源，展示更前沿的技术成果。期盼和各位再次的相聚，共赴这场科技与